In this video, we will be talking about the rules and practical uses of significant digits. We use significant digits to represent accurate numbers, data, and measurements. Many students find the correct solution to test problems, but they forget to use significant digits. As a result, several marks can be lost. Say you have a test question that wants you to solve for an unknown value. Most marks will come from showing your work and finding the right answer, but you still need to round your answer in a certain way to get full marks. Starting with the first rule, the numbers 1 to 9 are always significant. So if you have a number like 684, it has 3 significant digits because it only contains numbers that are from 1 to 9. Applying that same logic, the number 2649 has 4 and the number 56 has 2. Our second rule states that zeros found between numbers are always significant. An example of this is the number 202, as there is a zero enclosed between two other non-zero numbers, making 202 have 3 significant digits, and the number 4006 having 4. The third rule states that zeros found at the start of a number are never significant. This applies mostly to decimal numbers that are less than 1. So looking at 0.01, only the 1 is significant, while the zeros in front of it are not. Even if there are 100 zeros before the 1, there is still only going to be 1 significant digit, unless there is a number before the zeros, making all of them significant, like we learned from rule number 2. Rule number 4 states that zeros that end a number after a decimal are always significant. Looking at the number 100.00, we can see that there are 2 zeros after the decimal, ending the number. This makes these 2 zeros significant, as well as the 2 zeros behind the 1, meaning that this number has 5 significant digits. Finally, rules 5 and 6 state that when adding or subtracting numbers, the final answer has as many decimal places as the fewest decimal value. Looking at 104.6 being added to 200.03, we can see that the final answer is 304.6, as the fewest number of decimals is 1. Also, when multiplying or dividing numbers, the final answer has as many significant digits as the given number with the fewest figures. So say we have 800 being divided by 261. Our final answer will be 3, which has 1 significant digit, like the number 800. Now that we know the rules of significant digits, we can apply them to some practice problems. First question. A boy went biking with his friends. First, they biked 250 meters north, then 100.0 meters east, arriving at the park. What is the total distance that the boy and his friends traveled? This is a pretty simple calculation, as we're simply adding the two distances to find a sum of 350 for the total distance traveled. Now, here's where we actually use significant digits. Looking back at the question, there are 2 numerical values, those being 250 and 100.0. Because we are adding these 2 numbers, we make the final total have as few decimals as the fewest decimal number. Since 250 has no decimals, 350 meters is fine for our final answer, as it already has no decimals. Moving on to question 2. A candy shop charges $1 for 100.0 grams of candy. A customer places a bag of candy on the scale, containing a 20-gram lollipop, 200.0 grams of jelly beans, and 60.0 grams of chocolate. What is the total cost? To solve this, we must first find the total mass of all the candy, which comes out to be 280 grams. Using a conversion factor, we can then multiply the 280 grams of candy by $1 per 100 grams, essentially multiplying it by 1 and dividing it by 100, which gives us $2.8. When multiplying, we always use the lowest number of figures for our final answer, so we need to find the number given to us with the least significant digits. That number would be 20, which only has 1. Rounding 2.8 to 1 significant digit gives us a final answer of $3. Let's do one last question. A duck swims 20.0 meters into a river. The current then speeds up and takes the duck 80 meters downstream before it is caught by some campers and returns on land. How far did the duck travel? Again, pretty simple here. We just need to add the distances, giving us a total distance of 100 meters. For our final answer, we must look again for the given number with the lowest number of significant digits, which is the 80 with 2. The reason that this number has 2 significant digits instead of 1 is because of the decimal after the number. Putting the decimal after the 80 expresses that someone wants the number to have 2 significant digits rather than 1 or 3 by writing 80 or 80.0. You may encounter similar values like these in other questions, so stay on the lookout. Now, in order to make 100 have 2 significant digits, we must put this number in scientific notation, which comes out to be 1.0 times 10 to the power of 2 meters, giving us our final answer. So now you've learned the rules and practical uses of significant digits. You know how to tell how many significant digits your final answer must be in, and how to make it have the same amount of significant digits, whether it's by rounding your answer or putting it in scientific notation. For those who want more, here are some practice problems that you can try out yourselves. The answers are posted at the end of the video. If you've made it this far into the video, chances are you're learning a lot and enjoy the content. So if you don't mind, consider subscribing and dropping a like on this video, as it shows me that you like what you see, which helps me post more videos. Anyways, that's it for now. I wish you well and hope you have a good day.